Hi, ladies and gentlemen. Today I'm going to present you the conformational and toxic analysis of the ciclesonide molecule with anti-inflammatory activity. Here is the authors of this work. Ciclesonide is a non-halogenated, synthetic, inhaled corticosteroid with anti-inflammatory and potential antiviral activities. Today, it's commonly used in asthma treatments. Also, it's used in lung and breast cancer treatments, and recently found that it affects today's widespread virus SARS-CoV-2. And here's the use areas: SARS-CoV-2, lung cancer, breast cancer, and lastly the asthma. SARS-CoV-2, Shotoku Matsuyamas, Miyuki Kawase's, Naganori Naos, and Koya Shirato's study shows that ciclesonide suppressed the replication of beta coronaviruses MHV2, MERS-CoV, SARS-CoV, and SARS-CoV, and an alpha coronavirus that affects humans, HCoV 200 to 29E in cartilage cells. These observations indicate that the suppressive effect of ciclesonide on viral replication is specific to coronaviruses, highlighting it's a candidate drug for the treatment of COVID-19 patients. Pros of ciclesonide are it's safe, it can be administered to infants at high concentrations. As a result, ciclesonide is expected to be used as broad-spectrum antiviral drug against many members of the coronavirus family. It could be prescribed for the treatment of MERS and COVID-19 and lung cancer. In Hek Sun Choi's, Su Lim Kim's, Ji Han Kim's, and Dong Sung Lee's study, it's shown that ciclesonide inhibits the proliferation of lung cancer cells and growth of cancer stem cells. To regulate breast cancer stem cells formation, ciclesonide regulates GL1, GL2, SMO, and SOX2. These studies unveil a novel mechanism involving hedgehog signaling and SOX2 regulated by ciclesonide in lung cancer stem cells, and also open up the possibility of targeting hedgehog signaling and SOX2 prevent lung cancer stem cell formation. And breast cancer, Su Lim Kim's, Hak-Sun Choi's, Ji Han Kim's, and Dong Sung Lee's study shows that ciclesonide inhibits breast cancer and cancer stem cell formation. Ciclesonide-induced glucocorticoid receptor degradation was dependent on ubiquination. Ciclesonide reduced the protein levels of hypotransducer yes-associated protein, and GRCRNA induced a decrease in yes-associated protein expression and inhibits mammosphere formation. And lastly, the asthma. In Ronald Dahl's study, it's shown that ciclesonide is non-halogenated corticosteroid that is converted to its clinically above metabolite, desobutyryl ciclesonide in the airways. Pharmacodynamic studies have shown that inhaled ciclesonide has potent anti-inflammatory activity in patients with asthma and does not appear to have clinically relevant systemic effects even at higher doses. It's highly protein-bound and rapidly metabolized by the liver and thus has a low oral bioavailability. Ciclesonide is formulated as a solution for inhalation using a hydrofluoroalkane pressurized metered dose inhaler. This formulation delivers a high fraction of respirable particles that yield high lung deposition with even distribution throughout the lungs and minimal opharyngeal deposition. And here's the conformational analysis. The 6 lowest energy conforms of the ciclesonide obtained by conformational analysis. And here you can see the energy levels of the most stable 6 conformation of ciclesonide. The first conformation has a total energy of minus 1286.16 and kilojoule by mole, and has a relative energy of 0. And the second conformation has a total energy of minus 1285.25 kilojoule by mole, and has a relative energy of 0.91 kilojoule by mole, and so on. And we used a program called Osiris to calculate the estimation of toxicity hazards and physicochemical properties. And here you can see the toxicity risks. It's not mutagenic, it's not tumorigenic, it's irritant, it has not reproductive effect. And physicochemical properties: C-log P 3.69, solubility minus 5.45, MV 540, TPCA 99.13, and drug likeness 0.98, and a drug score of 1.22. And here's the references. And thank you for listening.